Alrighty, we are learning about decorators in Python. Decorators are a Python-specific way to modify or enhance existing functions. They're just Pythonic syntactic sugar for higher order functions. So it sounds like we could pass in a function into a function and do something with it. So let's read more about it. So a function can be used as a decorator if it takes a function as an argument and returns a new function. The new function can then be used in place of the original function. Again, this is typically used to modify or enhance the behavior of the original function. Beautiful, beautiful. Okay, so it looks like we do take a function here. We pass it into a function. And here was maybe the original function was this. And it looks like we could now introduce a few other things. Now, what is this here? Now, is this the decorator? Let's see. Let's mess around with some stuff, right? So file type. Let's see, this looks like a Nest.js type syntax or even Angular. So, okay, what's the big deal? Decorators are just syntactic sugar for higher order functions. These two pieces of code are identical with the decorator. So this is that @val counter, and without the decorator. Interesting, 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 interesting. So it looks like if we wanted to do without the decorator, we'd still need to have the function. Where is this process doc then, right? This process defined process. Ooh. So can we just build this function and then Python knows that this decorator is associated to it, I suppose? Let's see. So assignment, complete the file type aggregator function and decorate the process doc function with it. Okay, so let's just study this a smidge. So we have a val count. So the file type aggregator function assumes that the function it decorates will only have two positional arguments, a doc and a file type. Fix the wrapper function inside the file type aggregator to update the counts dictionary to accurately reflect the number of times each file type has been processed. Assign the result to the output of the decorator function. Interesting. So I'm not sure what we need to honestly update here. So fix the wrapper function inside the file type. So this guy, or this guy more specifically, update the counts dictionary to accurately reflect the number of times each file type has been counted. I see. Okay, so let's print doc real quick. Let's see what we're working with. So we'll say doc. That's fine. I'll leave that there. We'll say print file type, and let's wrap this. And let's see what we're working with, right? So I'm trying to see the file. You guys heard my video editor just making that pretty noise. Okay, so let's see. So welcome to the jungle. Interesting. Not really seeing very much here on the console, or makeshift console, if you will. Interesting, right? So I'm not entirely sure what we need to do, but I do think we're going to end up with this at the tail end here. File type to count. There we go. Okay, so that's what changed a smidge. So it looks like the function to wrap or the result. Something changed when we did this. Why? No, nothing's changing. Okay, so the type here, we have two txt files. I'm just not really sure what's producing the files. Is it the doc, right? So I'm seeing nothing. Okay, so inputs, we'll kind of shoot from the hip then, I suppose. So we have the file type. If the file type, maybe we could do a for loop, so for file in file type. But it's not really an array. It seems like it comes in already counted here, right? So we have two txt files, one MD file. So I'm not really sure what we need to change other than this, right? Let's see. If file type not in counts, okay. So we got the decorator part right, which is kind of cool, but the logic wasn't there. That's all right. Let's see. So this is the bit we need. Let's see what's going on. So if the file type is not in the counts, add the file type to the counts is what I'm seeing. And then if it is in the counts, it'll auto increment the file type in our object, or our dictionary rather. And then it turns the result to the function to wrap. I'm not sure about this. This is where it's hurting my brain. And it doesn't pass too. Okay. So it looks like we can remove this. Let's see. Okay. All right, we'll keep it moving. That's a bit headier, I would say. Okay, so args and quargs. In Python, args and quargs allow a function to accept and deal with a variable number of arguments. Args collects positional arguments into tuples. Quargs collect keyword named arguments into a dictionary. So tuples are just the parentheses and dictionaries are the curlies, right? At least in short. Now, from a syntactic standpoint, a little different on the memory side and the computational side, but from a syntactic side. So positional arguments are the ones you're already familiar with. They're the arguments that are passed in by position like this. Okay, so keyword arguments, little different. I see. So you're assigning the keywords to the arguments, but it doesn't matter the order. So this order matters. If we pass in a 3 here, it's going to be to the A variable. If we pass in a 3 here, but we assign it to B, or B is assigned to 3 rather, it'll still be assigned to the correct variable. Super cool. Okay, so note on ordering. Looks like we can do both. Oh, no, we cannot do both. This will not work. Okay, so here's the assignment is we're going to need to do some positional arguments, I imagine. So we spent a lot of time building better debugging tools for ourselves so that next time we run into a problem, we can solve it faster. Complete the args logger function. It takes a variable number of positional and keyword arguments and should print them to the console in the following format. Print each positional argument in order using asterisks as the prefix per line. For example, 1 and 2, hello, So each argument, a little bit not understanding here. So each argument just gets a thing before, but what's the quarks? Print each keyword argument in order using the asterisk as the prefix, 1 per line. Use the sorted function and the items method on the quarks dictionary to ensure that the arguments are logged in alphabetical order by key. So interesting. So let's print some of these, right? Now, what does this look like? I think that A, B, C, D, F, G, H, yep, that's correct. Okay, so we have the sorted quarks, and looks like the args come in as tuples. So I think what we could do is just say for arg and args return, right? We could say asterisk plus arg. And then I think we could just do the same thing here for quark in sorted quarks return asterisk, same deal, plus quark. And if we need to assign this to memory, I think it'll work. Let's see. Oh, that's my auto spelling saying that's not a real word. Okay. So these need to be toString if they are, So we have print args, right? Let's try this one more time. And what we could say is memory array, right? Just to start putting them somewhere. Say memory array dot append arg. We could do the similar thing here, right? Quark. And then I think if we print array, yeah, we get all these, but we don't need this. We don't need the blanks. I'm not sure why. Maybe we could split that, right? No. Oh, there we go. Okay, so we're getting somewhere, but we need to get rid of the parentheses. So split. How does that look? Boom. Okay, split there. Can we also just tack these on and split the other side as well? Will that work? No. At least so far, this is a bit hacky here, but I'll say args or new args, right? And then we can just do new args, right? Which would be new args splitting the other side, I think, right? It's a bit hacky. Let's see if that'll do. No. Interesting. How do we split multiple things? Let's take a peek, see at what they did for key and arg. Value and sorted args item. Fun. So that's a little bit of the first idea, but they just did it much cleaner. Okay, cool. We'll run with that. Moving forward. 8 decorators. Fun. Okay, so decorators, if your decorator doesn't care about specific arguments of the function it's decorating, then you can use the args and quarks syntax to make it more generic. Interesting. Function to wrap args and quarks. I still don't really understand the function to wrap it, to be honest with y'all. I really don't. Let me just think about it. So, oh, I see. We're passing that in. Okay, that makes sense now. Okay. I thought for a second just was like, we could label whatever we want there as a function to wrap. Okay, so assignment, complete the markdown to text decorator and convert MD to text functions. Convert MD to text. Here we go. This should be converted to this. Wonderful. You can use the split to split a list of things to a new line. Let's see if we say print args. See what we have here. We'll need to label it args. So here's our args in a tuple. Not really sure how to get it out of the tuple, but if we split it, here we have, let's see, Should say args somewhere, right? Args. Oh, air tuple object has no attribute to split. There we go. Well, that would be why. How to split tuples, right? How to split tuple. Interesting. Okay, so it looks like you just destructure them. But how do we destructure a tuple every time? It's a whole different thing, folks. That's a whole different thing. Okay, we're gonna peek see at the solution, guys. I really forgive me. I'm trying to move forward and just get to Golang at this point. Okay, so let's see. So define wrapper, and let's just review some of this code real quick. We have convert MD to text. Let's see. So this is just stripping the hashtags. I see. Taking the lines and splitting them. We're getting I in the length of lines, or the range length of lines. Yeah, we'll just keep it moving, folks. We will keep it moving forward. Okay, so decorators. Let's see, decorators review. Function decorators are fairly unique to, I'll say, Python. Wonderful, wonderful. Function currying, higher order functions and first class functions are not unique to Python, but they're unique to object-oriented programming, I think. Maybe not. Okay. Is it unique to Python? Unique to, wow. Okay, so common in most programming languages. Did not see that answer, but that is exactly what it is. It's very common, very common. Okay, guys. So that was a little bit rocky, but function decorators, I suppose they're useful to wrap functions and decorate old functions. I suppose when do you use a function decorator? When to use function decorators? Let's see. Use a decorator when you need to change the behavior of a function without modifying the function itself. Okay, so it's almost like treating a old function like a class to some degree, and you're like extending it with new functionality, I suppose. Good to know. Good to know. It almost gives you that like similar idea of hooks on the front end, I suppose, like custom hooks, where you just take like old logic and then make a custom function with it. But okay, wonderful use case. I've yet to use that. I use hooks, but again, that's more front end development, where this might make sense on a server. I guess in my brain, I'm trying to rack it to make sense as like a class for a function that you would then use the function as an extension of an old function. So it'd be like a class where you have like a human class, but then maybe you want to make like, or excuse me, you have like an animal class, and then you want to make a class for a dog. You would start it on the animal class because it would already knock out like a bunch of stuff for you. So I think in a similar fashion with decorators and functions, you could have like an original function, but if you needed just added functionality, you just extend upon it by making this decorator. So I'll definitely need to brush up on it, but it's a good tool to have in the toolkit. Guys, thanks for watching. We're going to move on to subtypes for the next one.